Okay, question 7. This is a polar coordinates question, and there are some quite easy marks in this question. So it's after the hardest question on the paper, so don't be afraid to go out of order and find the easy marks in this exam. Okay, so part A, in fact, is the easiest mark you can imagine. This is equivalent to this. We've just got to find out the value of k. So they want me to go from this to something like this. So, sorry, that's an equal sign. So if I multiply out the brackets, y squared equals 16 minus 8x, and if I add the x squared in, so x squared plus y squared equals 16 minus 8x plus x squared, I've just got to see that this factorizes as 4 minus x times 4 minus x, and I've done part A, so my k equals 4. That was only 1 mark, but nice satisfying start to the question. Now we've got to show that, okay, this polar equation of this comes to this, all right? So getting all the way to that is a bit of a challenge, but getting started is dead easy because they've asked us to put it in this form. So we're going polar, so I've got an x squared plus y squared, so we're doing A2 now. So I've got x squared plus y squared, which is just asking to be called r squared, equals 4 minus x. Well, that's 4 minus x is r cos theta squared, and I've got a polar coordinate in one go. Okay, and I think there are 2 marks for getting this, even without making r the subject, though that's what we have to do next. So, right, I've got a squared thing, I've got a squared thing, so r is going to equal 4 minus r cos theta. Actually, technically you should consider plus or minus, but the exam, they've actually been kind. They asked you to set it up this time way round so that when you chose the square root, you'd choose the one that gave positive r. We'll double check that at the end, but if we'd made the opposite choice of sign here, we'd get an equation that leads to negative r. Okay, so we need to make r the subject, so let's get the r terms on one side. R plus r cos theta equals 4. That's just adding r cos theta to both sides. So I can take out a factor, r brackets 1 plus cos theta has to equal 4. So r equals 4 over 1 plus cos theta. Okay, which is lovely. It just happens not to be the final answer I'm aiming for. But at this stage, we can see that 1 plus cos theta is always positive. There's actually, when cos theta equals minus 1, we're actually going to get things tending to infinity. We're not going to get anything negative out of this. Whereas if I'd chosen the other square root, okay, I'd have had a sign difference, and I'd have had negative r's. Because this 4 would have been a minus 4, this would have been a bracket of 1 minus cos theta equaling that minus 4, so I'd have had 4 divided by 1 minus cos theta, which is always negative, except where it tends to infinity. So we've got the right r, but we haven't put it in the right form, because they wanted us to have 2 sec squared of theta over 2. Now that is that division by 2, that's the giveaway, all right? Because we've got a half theta here, we've got a whole theta here, so we must be using double angle formulae. So cos of 2a equals, well, I've got a choice of 3 things, okay? So 2a is going to be my theta, because the thing I'm aiming for has just got a theta by 2, which is going to be 1a. So cos 2a equals, well, which of the 3 things do I want? Well, one hint is that I want sec squared in the answer, which is related to cos squared. But the other thing is that the form with cos squared in, 2 cos squared a minus 1, that looks like a good thing to do anyway, because this minus 1 at the end is going to cancel out that 1. So this is going to equal, r is going to equal 4 over 1 plus 2 cos squared of, well, theta is my 2a, so my a here is going to be theta over 2, okay, minus 1. All right, so the 1 and the minus 1 are going to cancel, so I'm going to get 4 over 2 cos squared of theta by 2, and I'm going to have some cancellation here, 2 over cos squared of half theta, but 1 over a cos squared is sec squared, so this is 2 sec squared of theta by 2 as required. So that's the next 4 marks. Now, that was a little bit sneaky maybe, but notice the next bit is a re-entry point, okay? So don't let yourself get demoralized. We're now doing polar equation, tan theta equals root 3, and that intersects the parabola at the points P and Q, and I've got to find the full details of P and Q. Okay, so it's telling me what tan theta equals at P and Q, so effectively it's as good as telling me what theta is. So we've got some very easy starter marks here. If tan theta equals root 3, I can just inverse tan that to get theta equals, well, it's pi by 3 that has a tan of root 3. But I've, of course, got the normal range of values for theta. So it tells me that we're using theta's between minus pi and pi. So therefore, I've got to get the other solution, which is minus 2 pi by 3. I've got to take pi away to get the other solution for a tan. So I have these two values for theta, and now I've just got to work out the r's for those thetas, and they've kindly told me that r equals 2 sec squared of a half theta. Okay, so I could halve these and find the cos, or I can just put my theta values into this. Of course, if you couldn't get anywhere with this and you're relying on their version, you have to substitute into the sec squared half theta. So yeah, I'm going to do that way. So a half theta is two possibilities, pi by 6 when I halve pi by 3. So 2 sec squared of pi by 6 equals 2 over cos of pi by 6 squared. Cos of pi by 6 is root 3 over 2. It's 30 degrees. Your calculator can do it. Okay, so that's 8 over root 3. Oh no, the root 3 is being squared, so that's 8 over 3. And half theta could be half of this at minus pi by 3. So r would equal 2 sec squared of pi by 3, which is 2 over, well, cos of, sorry, minus pi by 3, but cos of minus pi by 3 is the same as cos of pi by 3, which is a half, so it's 2 over a half squared, which is 8. So my points P and Q are an r of 8/3, r comes first, with a theta of pi by 6, and an r of 8, and a theta of minus pi by 3. Sorry, these are my half theta values. That's a pi by 3 and a minus 2 pi by 3. Okay, so make that minus really clear. I'll just about get away with that, I think. Right, so I've got these 2 points. Okay, and I'm ready to go on to the next bit. So I've done dotty 1. Now I've got to get the area of the region. Well, hang on. Now I've got to consider 2 areas. This region and this circle. And you know what? Okay, especially if I'm running out of time, I'm going to pick up the 2 marks for finding out this second area, because that's just a circle. And I think I can do that. Okay, a diagram will help. All right. Now the curve, it tells me somewhere that the curve is a parabola. I haven't sketched it. I don't think I really need to try and get an accurate sketch, okay? But I do need to know where these 2 points are, so I can think about the circle. So if the pole is here, then I've got 8/3 on an angle of pi by 3. So pi by 3, and we've got 8/3, and I've got 8 on an angle of minus 2 pi by 3. Okay, and we commented earlier there's a difference of pi here, and I think for the other one I will need to know that this is a straight line. So this is through the pole. So this is 2 pi minus 2 pi by 3 that way, but this distance is 8. And the circle with that as a diameter, so the diameter equals 8 plus 8/3, which is 8 is 24/3, so that's 32/3. So the radius is 16/3, and pi r squared, which is the area of a circle, will be pi times 16/3 squared, which is 256 pi by 9. So that's my A2, which just leaves me with the area of the region bounded by the line segment PQ and the curve C. So I can see that I'm going to have to set up an integral, okay, using these 2 as limits, and the curve will go between P and Q. Now, if I'm being really, really careful, I have to care about which way the curve will join up. This can't be a closed curve. In fact, I noticed before that there was a value of theta that made it go towards infinity. When we were checking that this was always positive, we said that it would go towards infinity when cos of theta was minus 1. That's when 1 plus cos theta would be 0. So the angle with the cos of minus 1 is pi. So therefore, in this diagram, along this line where theta is pi, this is where it's going to run away to infinity. So it's kind of going to be a parabola that way around, I think. Anyway, the bit that doesn't have that problem is a bit on this side. So that justifies what you'd have probably done anyway, which is setting up the limits with minus 2 pi by 3 and pi by 3. Okay, and we know that it's pi times, half times the integral of r squared d theta, and all you've got to do is fill in what r is. Now, this is where they've tried to be kind, because they told you to get r equals this. We could have stopped with r equals, what was it, 4 over 1 plus cos theta, okay? But they've gone out of their way to tell us that r is going to be that, so that is their hint about how to do this integral. So, as long as you put a correct expression for r here, okay, I think you actually get 2 marks, especially, you definitely do if you put this expression. So that is worth 2 marks, as long as it's got the half and it's got both correct limits on. Okay, so that's actually 4 marks we've got out of this last 9 without really doing anything difficult at all. Now I've got to integrate, well, I've got 2 squared, which is 4 times a half, so I've got 2 outside the integral. Okay, I'll put my limits on. I could miss them off and be lazy. Okay, so basically I'm integrating sec to the power of 4 of theta by 2. Okay, so I'm not really too bothered it's a theta by 2, but how do I integrate sec to the power of 4 of something? The inspiration you need is from the fact that we've been thinking. We know there are a lot of FP3 questions that you do integrations with a helper, and a very common helper is sec squared of something. So if I separate off sec squared of theta by 2 here, d theta, then obviously the other bit is going to be sec squared theta again. I'm going to have a 2 outside there. So what kind of thing would I like this to be if this is going to be a helper? I'd like this to be something in terms of a tan of theta, but that means I'm going to have 1 plus tan of theta by 2. Okay, 1 plus tan squared, because sec squared theta is 1 plus tan squared theta. Sec squared theta by 2, which is what I've got, is 1 plus tan squared theta by 2. And so this is going to be a helper, so this is going to be an easy integral to do. Okay, now on these helper ones, sometimes you'll just see how to do it by inspection. If you multiply out this bracket, probably not going to be too bad, but the substitution that will work, and I may have said something, I did say something wrong in class the other day, okay? The substitution to go for isn't the whole of this bracket. The substitution to go for sec squared of the angle to be a helper, I would like my substitution to be u equals tan of the angle, the thing that differentiates to this, okay? Well, actually, I need 2 of those to differentiate to that, but it's close enough. Okay, so u equals tan of theta by 2 is going to work beautifully as a substitution, because du by d theta equals, differentiate tan of kx, we get k half sec squared of the same kx. Okay, so therefore du equals a half sec squared theta by 2 d theta. Okay. All right, I could make d theta the subject of that, but I can see that a half sec squared theta by 2 d theta is there. So I just need all of that stuff is just 2 du. So I'm going to have 2 times the integral. This bit is going to turn into 2 du, and this is just going to be 1 plus u squared. So I've got a 4. Whoops. All right, did you miss that? So the sec squared theta by 2 d theta, I can see changes into 2 du. That's where that came from. And the 1 plus tan squared theta by 2 turned into the bracket of 1 plus u squared. So I've just got to integrate 1 plus u squared. There's a 4 in it. Okay, I've been forgetting about my limits. I need to put those back. 1 integrates to u. Okay, and theta squared and u squared integrates to a third u cubed, and my limits, well, if I update my limits, I mean, I could just turn this back into tan theta and tan theta there as well, but I can do it by updating my limits, because I've got 2 angles minus 2 pi by 3 and pi by 3. They're the values of theta. Okay, my u values are the values of tans of half of those thetas. So when theta is the bottom limit, minus 2 by pi by 3, I need to know that tan of minus pi by 3 is minus root 3. Okay, and for the top limit, when theta is pi by 3, half of that is pi by 6, tan of pi by 6 is 1 over root 3. So I've got to put those in, so I'm going to get equals 4, 1 over root 3 plus a third of 1 over root 3 cubed, and I need to take away from that minus root 3 plus 1 over 3 times minus root 3 cubed. Okay, and I need to pick all the bones out of that. I could just enter that in my calculator. And if you do, your calculator will give you the beautiful exact answer of 256 over 9 root 3. And that's our A1. Okay, and A2, which we had before, was 256 pi over 9. So I can therefore say, what did the question ask me to prove? It asks me to do A2 over A1. So A2 over A1 equals 256 pi over 9 divided by, so times the reciprocal of, so 9 root 3 over 256. So that cancels, 9's cancel, and I get up with this beautifully simple answer of pi root 3. Sorry, you couldn't see any of that. But once you've got the A2 and the A1, I mean, you just say that divided by that equals the answer, and you've got full marks. Okay, so that's the end of question 7. Hope you enjoyed that.